let's see, close all that. Okay, so if you want to get to Jupyter, go to Jupyter. Oh, my browser's locked, so I gotta, okay, boom. Yep. So I use Community because that's where everything I do lives. And a couple things, in case you haven't seen this, you could actually do like a fun live little demo here and predict, and it'll show you which variant is returning. So you can predict again and see, okay, so it looks like maybe we shifted it over to, somebody shifted it over to just B. So we can actually shift over to just A by just a click of a button there. And now only A is returning, and we should see A lighting up and B dying down. Now, what if we want to do traffic shadowing? So say we have new version B, we actually don't want B to return to the user, but we still want to send traffic to B, and that's exactly what's happening here. So we have 100% of the live traffic going here. We're splitting so that 100%. So all the results come back from this variant A. And like there's ways to do 50-50 or 75-25, but for the demo here, I just have these increments of 50. And we can have traffic shadowing. So B is still going to get that traffic on a sort of best effort basis. It's fire and forget. It's not actually going to affect traffic going to A. And this way we could actually have internal dashboards that see how is the new model, that new variant doing, but not affecting production. So model A is still actually returning the results. And if you do get into a case, I think I could make pretty, I think if I do like this, it gets a little confused. Okay, but you could actually fix the prediction. Now, I don't have the UI part of this, but when you fix it, this actually goes into a like retrain queue. So we're using, of course, Kafka behind the scenes, and there's actually one other piece to it too, where it will fire up and send a message to Slack, and you could actually relabel directly from Slack. Yeah, which is kind of fun. So either relabel it here when we predict, since this usually wouldn't be shown to the user like this, it will detect any sort of unconfident predictions based on the type of model, right? Like usually we're getting back some kind of like confidence score from this prediction. And here, if there was a certain threshold where it's 10%, 10%, 10%, we would actually like detect that, send it to Slack. It would pop up. The actual image would pop up, and we would ask the human to actually relabel it, and then from Slack, it then goes into Kafka for the retrain queue, and we're constantly training and pushing out newer versions in this shadow mode. This part's kind of cool too. We actually have a little curl thing here. You can pick different languages. You can even embed it as jQuery, JavaScript. If you want to get your Java on, you got that there, and friendly Node.js. So you can actually grab the snippet, even the shell, and just run it. And yeah, just want to highlight that we do have these articles. We do have Slack support. We're seeing a lot of people move off of the email support onto Slack. For some of our like larger customers, we're actually creating private Slack channels with these folks because they are sending us a lot of feedback and have a lot of questions. And yeah, so that's been really valuable. So, and also, if you do want more than just this 1 hour here, we've got these workshops coming up, and you can sign up. Click over here. Like Eventbrite will show you some upcoming meetups that we have. We actually have a meetup tonight that's going to be really cool. So check that out. And these are the actual full day workshops that we're doing. And then also we tend to do some 4-hour ones on the weekend as well. So we mostly have California, but I think there's one in Boston coming up in line with the ODSC conference, Open Data Science Conference, and a couple other things. So check that out. Okay, so we have TensorBoard running here. It's probably going to show nothing because we haven't really done anything, but we can run some jobs here in a sec, some TensorFlow training jobs. This is just to show you Kubernetes is powering this. Like again, this would not actually be user-facing, but since you are likely users that are interested in this type of stuff, we do expose it. This is just a full link to, if we had a whole ton of models running beyond A and B, we would see all of them there. Here's a bit of our serverless kind of situation. So I think some of you already found it here. So this is actually based on this project called OpenFOSS. And for us, all it was just adding a FOSS label to it and FOSSNetties label, and Kubernetes picks it up. So this was our way of proving out that we are a true serverless platform specific to machine learning. So, but yeah, you can deploy your own. So you see there's predict MNIST A, predict MNIST B. We can actually go in here and copy and paste the like JSON for a sample image, and that's how we would do that. Okay, so let me jump back here. You have Airflow. Yeah, it looks like some of you already started turning these on. So a lot of these don't work right now. They're just not wired up properly. They're actually sort of older DAGs, but we wanted to get the connectivity there so we could start playing with it. Right. So again, there's going to be rough edges here. There's going to be a lot of sort of disparate UIs that you're seeing, and this is us sort of experimenting and doing our own A/B testing on our product and seeing which parts stick. This is showing we have the new Spark 2.3. We've got the Kubernetes stuff turned on here as well. So Spark using Kubernetes. And then here's something new. So this is PipelineAI, and this is a way. So one of the features of Pipe that's coming out is we're actually collecting data at every step of the pipeline. So from training, so there's no data in here just yet. We can get some data in. I could actually jump to the command line and get some data in here, I think. One sec. Show you guys what's up. Let's see, test, scikit, boom. Okay, someone's raising their hand. Do you want to just type it in there? Yeah, Monica? Monica? And let me do test basic. Okay, people who are raising their hand, make sure that you type in the question into the chat box over there. Okay, let me refresh this here and we should see some data. So this is kind of cool. So we actually just did a simple Python script without any scikit, and then we did scikit here. We did a grid search. We're getting some results here. We can actually filter on some of these things and different ways to slice up these different model runs. So I was testing this morning, just making sure that we had the connectivity, but here's a bunch of different runs. You can click on them. Here you actually see the scikit flow. And so, but like keep in mind too that we're also tracking data per run on which type of EC2 instance was used. And so we can go look up the profile. These EC2 instances or these Google Cloud instances, Azure Cloud instances have very well-defined names with like well-defined specs, 60 gigs of RAM, 8 cores, 2 GPUs, 2 K80s, 2 or like 64 of the V100s. And we are then able to make recommendations. So this is sort of the training side hyperparameters, but keep in mind also that when we go to serve these models that we're collecting data on the like prediction inference side also. And this supports R, we support TensorFlow, of course, we support, this is showing scikit and simple Python, even simple Python, which we're seeing more and more people using for ensembles. And that's actually what like a lot of people use some of these functions for. So this UI is going away, but it's kind of slick because yeah, like we like this invoke thing here. It's kind of like Postman. But yeah, so let me jump back here. Yeah, so because we're actually tracking data at all parts of this pipeline from training into production serving and like the inference side, we can then close this feedback loop between offline hyperparameters and online hyperparameters. So this is one thing that not a lot of people think about right now anyway, because most people who are building the models just kind of release the model to the production team and they'll rewrite it or they'll like push it out and they have their own dashboards, and we're actually combining all these things. So we're working pretty heavily on this where this particular line item, or if you drill in, you'll actually be able to see the online metrics and see it'll be a combination of this dashboard here showing it right next to, yeah, so these are like disconnected samples right now because we're like actually working on pieces separately and then bringing them together. So by next month, we'll actually have a unified view of all this. And yeah, so the model DB is pretty cool. I don't see any questions showing up in the thing here. So if you do have questions, please post them into the chat window over there. Okay, and Airflow and Spark and the pipeline DB stuff. And then we just have some kind of cursory UI for S3 exploration. So we are working on a unified object store, so we can actually see into S3 the same way that we see into Google, same way we see into Azure. So like we actually picked up a super large customer over the past couple weeks who we've been working with them pretty closely. We have weekly calls with them, and they need the sort of hybrid view of all of their models across all different object stores. So working pretty closely on that. That project spun up with the new guy that we brought on. And if you go into Jupyter here, we should be able to actually train. So a couple places. Yeah, it looks like some of you might have already hopped on here. So let me just actually close all these things here. You should have your own instance using that allocator link. Some of you, if you're having problems with the allocator, allocator or Jupyter, you likely have firewall enabled or VPN. You need to get off of those. So Jupyter and the allocator actually use WebSockets and different sockets than port 80. So we actually see some people, like specifically at this scale, there's going to be about probably 5% that have issues getting. So let's see if I can actually, oh yeah, it's already populated data there. Let me go into notebooks. And the GPU workshop, this is the actual full workshop. And so let's do, oh, and then here's an example of the new dataset API from TensorFlow connecting to S3, which is pretty slick. We also actually have an example, looks like I haven't put it in here, where we're pulling from Kafka. So let me, actually I can demo that. Let's see, stream private. Do I have the test here? I thought I had a test one in. Wonder if that's sitting on another server and I haven't committed it, but yeah, we could actually pull from Kafka using the natural TensorFlow dataset API, which is pretty slick. And all of the threading and all that stuff is happening behind the scenes. So here we read from a single machine and we've specified a bunch of, the S3 bucket comes from up above, number of workers, number of parallel readers, batch size. One thing that you'll want to pay attention to in dataset land is this concept of prefetch. This is actually, there's a good link here now. There didn't used to be, but there's a good link off of TensorFlow. One place I spend a lot of time, oops, sorry, hang on. Place I spend a lot of time is when they're developed and performance. And this is where a lot of the full workshop, the full 4-hour and the 8-hour workshop, we spend a lot of time on this JIT compilation, this XLA business, the AOT. So there's like just in time, there's the ahead of time compilation. This is using TF compile to minimize the runtime footprints of our model. And this is super important, especially on these smaller devices. So check that out. But the one thing keep in mind, performance, this input pipeline performance guide. So man, this is the #1 question that we get asked, especially because we're really focused on the entire pipeline and the ingestion, and then also GPUs and these new TPUs and these custom ASICs that are being developed for these neural network type workloads, deep learning workloads. And this is one area that people cannot get enough knowledge here is how do you actually use TensorFlow for ETL? So this is where you see TensorFlow bleeding into Spark's domain a bit, and this is definitely not for the faint of heart here. You will be on the bleeding edge here, and especially using the Estimator API. But there's ways to actually have TensorFlow and then TensorBoard actually tell you where you're doing things wrong and where you're not, where you are losing out performance. And okay, here's that prefetch. So spend some time there. What this is doing is this is kind of the first attempt to give people the ability to size up and to create buffers of their data and get them pre-processed quickly so that we could saturate these accelerators. And really, this all comes down to the network, quite honestly. So especially in distributed TensorFlow and the way that Google, for example, mounts these TPUs and their GPUs, actually, they don't actually have them on the same board as the Google Cloud VMs. They're actually network connected. You know, it's a form of InfiniBand, and it's super high speed connectivity between the CPU and these GPUs and these CPUs, but there still is a remote call, and that's very different than the way that Amazon handles. When you provision on the Amazon side, you actually provision the entire thing, CPU plus GPU, and that's one instance type. On the Google side, in sort of preparation for these TPUs, you know, these are separate racks of just TPUs and just GPUs with their own cooling and their own switches to and from. So it's very important to realize that difference. And if you're doing performance benchmarks on Amazon and you think you have a similar profile and Google seems a bit slower or something is sort of wonky for the same setup with the same types of GPUs, just keep in mind that there is a bit of a penalty to get the data over to these TPUs. And really, there's not much you can do about data locality. The recommendation from Google is to put everything into Google Cloud Storage, of course, when you're using their stuff. And on the Amazon side, of course, they're saying put everything into S3 and we can get data to these accelerators quickly. Okay, so tonight's meetup, which we are going to record and post on YouTube at pipeline.ai, is going to involve the TPUs. So let me show you a quick slide on the TPUs. There's about 5 or 6 slides here. So my buddy is filling in the actual details, the performance details. I'm going to meet with him later today before the meetup. But you know, these are what they look like. Here's those pods, which are 256 of these things. Google's on their 2nd generation TPU that are more generic and can handle more of the training workload and but still be pretty good at the inference. Now, one thing about TPUs right now, I was just speaking with the TPU product manager the other day, they're not yet optimized, or sorry, TensorFlow serving is not yet optimized for TPUs, or that code hasn't made it into the open source. So on the training side, that's their current focus. You'll see a lot of these estimator APIs. In fact, I think that's the next slide. Fix that. So the training side, you'll see this stuff where you actually have to use your own TPU estimator. And this is different than the regular estimator, which we've been using for our GPU and CPU training. So just keep in mind that there is a different first-class citizen here, and also there's a different optimizer. So you know, these are contrib packages right now within TensorFlow. So these are very first-class contrib projects, but they haven't made it into core, which is kind of interesting. So TensorFlow Summit's coming up in a couple weeks, and we're actually going to do a shared blog post with Google and the TensorFlow group on TensorFlow serving and the TPU estimators and like a bunch of TPU stuff. So yeah, we'll hopefully get the full story on this then. Okay, and then yeah, so cross-shard optimizer, it's kind of a goofy term. It's how these TPUs are like architected. And backing up to the slide again, we're actually working with some custom ASIC chip makers that are building something similar, and they're like diving deep into XLA and you know, how the just-in-time compiling is being done, and they can learn a lot based on the implementation. This code is open source. It's just not part of TensorFlow Core right now. But yeah, obviously Google trying to push people to Google Cloud, and these TPUs are specific to Google Cloud. You can bet that this code will be super stable, yes, even though it's in the contrib package. So this is what I was talking about. You know, here's where you could see some prefetching happening here, and so helps print on that. Right. So here, this is earlier in the pipeline than what we've been able to profile so far, which is more on the actual chip itself. Like, show me where is data, or rather, where is time being spent between the CPU, between the GPU, or separate from GPU. Just show me where's time being spent on the CPU, and like which operators are expensive, which ones, if we're using XLA or some kind of just-in-time compiling, we can see that like just-in-time compiling happening, and like various operators fusing together. But this is really focused, this particular view, you just kind of scroll to the left in a time series manner, the stuff that like leads up to the GPU and the TPU profiling. There's still quite a bit of things that like we can optimize on the actual pipeline, rather getting data in. So here's another view. This, some of you probably have seen, there's a new little checkbox here called TPU compatibility, where you know, this is a clever marketing tool from Google, where because they pretty much control the entire TensorBoard project, and you know, they can like slip these little subtle things like, oh, by the way, if you use our TPUs, you know, 92% will have a performance gain, or can be compiled for like TPUs with this current version of TensorFlow. And yeah, obviously that's going to go up and up and up. So it kind of whets your like appetite. And one thing we'll be doing as far as pipeline, we're actually going soon to be releasing a way to test your models on CPU, GPU, TPU, which is a huge like use case that actually people find us for. Is we know that we can spin up a GPU, or like we now have access to TPUs, but we don't have the like Docker image, or you know, a way to package up our model, and right, just to try these things out. And so that's exactly where Pipeline comes in. So keep an eye on that. Go sign up for the community edition if you haven't already, and you'll be notified when that's available. So you'll be able to upload your model, train it, get the performance metrics in a similar manner here, and show you not just what could be possible, but how specifically they compare. Right, like from, yeah, so this is kind of projected, you know, like, but it doesn't really, it's just showing what can be compiled for TPU. In some cases, your model actually ends up slower, right? And it's because the particular operators that you're sending to the TPU, they either haven't been compiled proper, or sorry, they really don't have TPU versions or not optimized TPU versions of those operators. They might work at a bare minimum, but what you want, you know, is right, yeah. So from like a full like sort of view of what's going on here, right, like you want to be able to see how your actual model does on these chips themselves. Oh, and then also the like network connectivity thing that I was talking about before, that's what I was going to say, is you might actually slow down training or slow down inference because of that like latency between the main VM and the TPUs. So there's this Cloud TPU profiler, and this is on pip or on PyPy, so you can install this yourself. And right, again, this is specific to TPU. There's also another tool, did I mention it over here? That's called like TPU-C or something. If you go through the Google Docs, you'll see there's this command line tool that helps you like provision these cloud TPUs. So they're really making it as simple as possible to get access to the TPUs. So here's a quick screenshot of what we're seeing, and down to the actual like flop utilization here, 41%. Actually looks kind of good to me. 69% looks super good. Convolutional level, this is us drilling in and seeing different things, but you'll start to see where on these TPUs, we're actually able to show the layout. And this is pretty hardcore, but this is starting to expose parts of your training that are hardware specific. And really, right, like with just a little bit of explanation, like this stuff starts to get more and more intuitive, and the ability for you to make changes and see like how they affect here. So this is actually one of the benefits of Pipeline, again, is that you can set these hyperparameters, you can change the batch size like super quickly and deploy these as experiments. And yeah, Pipeline runs inside of your cloud account or on-prem. So just as long as we can get to a Kubernetes cluster or can get to like raw EC2 instances, we're in good shape there. So yeah, you can deploy our stuff in the privacy of your own data center or cloud. We are going to accept models, but with from the managed service side of things, but with the caveat that this is sort of just a sandbox environment, right? So right now, Community Edition is totally wide open. Yes, anyone can join. Any data that you put there is totally open to the public. The real product is like this like enterprise product that actually installs inside of your own VPC or on-prem. Okay, and that gives you the easy ability to spin up different examples like this. And so yeah, this is like another slick little tool here. This is kind of human readable, and this is going to help you determine if your pipeline is truly input bound. This is a term you'll see. Most people would say IO bound. Google actually, in the spirit of doing their own thing and having their own terms for everything inside of the Google bubble, they just call it input bound in like a lot of the documentation. And basically that it's in the training context when you're trying to feed data into these accelerators, that's exactly what it is. So percent of time for the device time waiting for input data. You can see a little chart over time there, which is kind of slick. Okay, so we will be posting the video from tonight. We're going to get into more benchmark stuff. We're actually going to do multi-TPU training right before your very eyes. You've got the profiler. We're going to show that on the complete input pipeline. And yeah, so that'll be tonight. And we'll post that in the next day or two. Okay, so let me close out some tabs here. Let's get something into TensorBoard. Okay, so I showed you guys that. This is also the eager execution. So there's an example here. This is also contrib, but this will be moving into core TensorFlow. This is a fancy way of saying that we can be just like PyTorch. TensorFlow is often criticized for being too performance focused and too, well, yeah, so people don't actually say it that way, but that's basically what they're saying. Given a trade-off between being a research tool like PyTorch and even R and Scikit, right? So these things were like designed for experimentation, offline experimentation type capabilities, and not optimized for the actual runtime and sort of real-time prediction making. And that's really where TensorFlow crossed the line into more performance. And if you notice, the default TensorFlow flow is like the way that you would read the code. It's very similar to Spark, how you're kind of lazily building up this like DAG, this graph of operations. And then at some point that graph gets executed. And for the exact same reasons that Spark does it, the ability to build up a logical plan and then be able to optimize it for specific devices, or right, like if you want to put a filter before a join and things like that. So, but this is one part of TensorFlow where they're like, all right, if you want to be like PyTorch, then just turn on this like eager execution, and we will actually execute these things just like they are in PyTorch and scikit and R. Just know that when you're done, you'll have a graph that can then be converted, right? Like it's super simple to actually convert this into something that can then be just-in-time compiled and all that. But so it's kind of a nice natural way to stay inside of TensorFlow. So traditionally what people do is they build in scikit, or they do the research in scikit, they do the research in PyTorch, they get the weights, and yeah, so they'll train or they'll sort of experiment, and then they would either convert it into TensorFlow or rather convert it into something that can be just-in-time compiled and make the training faster. And then there's a third step of actually taking that like training model and slimming it down for serving. So yeah, the short of it here is, if you are super annoyed by the sort of that graph building step where it's like being lazily executed, you can force it to be like the tools that you're familiar with. But just know that you'll want to then convert it back into TensorFlow's native, where these optimizations can be applied. Okay, so you can play with that. Let's see, let's actually train a model here. So let's just do the GPU ones for time's sake. You'll see that we're actually allocating some things onto the CPU in this, and I get into full detail of that during the longer workshop. Let's see, yeah, and also keep in mind that some of these things don't, or actually a lot of the things that are in this workshop have to be compiled from TensorFlow source. So you won't get this command, for example, summarize graph. I believe there's a Python API version of this now. I wasn't having much luck with it at the time. Also, if there's a snippet of code that you want to grab from this talk, grab this piece of code. This is what gets you the ability to actually plot the exact graph. So this is TensorFlow. This is linear regression after it's, and I'm calling it unoptimized because this is after training, but before it's being prepared for the inference. There's actually a new visual debugger now for TensorFlow that has creeped up. So I've modified the actual workshop. Looks like I haven't updated this one yet, but yeah, so there's like a new UI. It's kind of part of TensorBoard, I think, but it's still a bit disconnected. All right, so I'm going to follow my own warning here because I do tend to forget this, and it looks like there's a lot of other people on here. So I want to kill this. I want to restart this one here. And before anyone else hops on, I want to run this. So this is actually optimizing. Oh, yeah, no, this is turning on XLA. So this is unoptimized XLA. And we could actually go and look at some of the XLA stuff here. And I'm going to compare. Did this generate those? Yeah. Okay. So here's actual steps that are happening. This is the just-in-time compiling, the fusing these things together. Let's see. This is various steps through. So the first step through, it was able to detect this. 10 steps in, it's collecting more data, and we're slowly able to fuse some layers together and do some fun stuff. So actually, I want to show you guys. Let me download. So the way to do this here right now is you have to download these locally. So it's this timeline GPU and XLA GPU. I'm going to use this Chrome plugin called Web Tracing Framework that's actually was built by another group. And TensorFlow is just reusing it. Where's the downloads? Get that guy. Let's take a look. So here you'll see the fusing together of these layers. So XLA GPU. I want to show the other one too, though. Let me show this one. I don't know why it didn't download. Side by side. So Chrome. You have to install this Chrome thing. I'm not sure if it's installed by default. Let me grab just the regular GPU. So you'll notice, let's see, the timeline's a bit skewed here, so I think I can broaden it away. Oh, that's not it. let's see. Forget how to actually broaden this, but you'll see a whole bunch of operators here, and they've been fused into one operator. This time scales off, right? 0 to 500 is only this big here, and it's this big over here. So, but there's a whole bunch of little operators happening. This is a lot of memory movement and a lot of cache, like thrashing and like that kind of stuff, versus one function, one kernel that's being executed on the GPU. So that's pretty cool. Okay, and let's see. So this is some of the transformations that are possible. That's looking for, let me train the CPU one here real quick. I think that one uses the CPU. That's the other one here. Okay, so let's make sure that we have the model, an optimized CPU. Yep, it's there. We can inspect it using the summarized graph command line. This is basically, you can get this information from TensorBoard, which, by the way, we should start seeing some graphs over here, and we do. So it looks like a bunch of people have made some runs. I do want to look at XLA GPU here, training. Let's click on device. You can see green is the GPU, and blue is the CPU. So I mentioned earlier that when you're looking at the GPU code that we have inside that notebook, we actually explicitly assign the weights to the CPU. And that's because this is a very, very simple operation. There's only 2 weights here, but if there were, right, like 1 million parameters that we're learning, that would all have to sit inside the GPU, and we definitely don't want that. At minimum, we want to put that on the CPU because the CPU can access a whole lot of RAM. And potentially in a multi-node cluster, we would actually have to introduce a what's called parameter server, and that classically would spread over a bunch of CPUs, and all of the weights are stored there. So, and distributed TensorFlow hides a lot of that stuff. Okay, so this actually has 100% TPU compatibility, and again, it's using all of the backprop. This is all the backprop stuff here. Inside of that, and then we're just doing matrix multiply and then matrix vector add. These are all very, very simple like operators that have full TPU compatibility. So this is one where we'll actually do kind of a side-by-side comparison. So actually, there's CPU, there's GPU, there's the XLA GPU, there's TPU, then there's XLA TPU. We haven't yet tried the XLA TPU stuff. Actually, that's something I'm going to talk to my TPU guy about today in preparation for the meetup. Okay, so when you do stuff here, it's going to show up in TensorBoard over there. We can actually run some of these transformations here. So that's that same graph I was showing you earlier. Here we're going to strip the graph, make it smaller. Let's actually just visually look at what it looks like. Boom. So with one command, we actually stripped. And there's these pesky identity things that are useful during training time, but they're not useful at inference time. So we're going to explicitly strip those out. We used a command here called strip unused nodes, and then the remove nodes, and explicitly call out the identity one. So let's keep going here and look at what that looks like. And there we go. So from there to there, we no longer have the identity nodes. So this is improving performance at inference time, reducing the size of the graph. We're not actually using batch normalization in our sample here, but this is where you fold it in, and then here's quantizing the weights. So yeah, by the way, this is all out of the box now from Pipeline. You can actually call these things, so it's not as clunky as doing all this stuff. This is kind of the raw TensorFlow way to do it, and again, you have to build TensorFlow from source. And yeah, we have all the Docker images and everything compiled and built from all the various sources and have TensorRT, which is another optimization layer. So that's all built into our Docker images in our platform. Here we're preparing the model for serving, then we actually deploy it. And we're using TensorFlow serving here. So yeah, so this is more on the workshop side. If you do want more info about pipeline and how to actually like package up and deploy your models and hyperparameter tuning and all that, you can go to quickstart.pipeline.ai. Let me post that in here. Quickstart.pipeline.ai to follow to train, package, and deploy your models using PipelineAI platform. And so back to what I was saying earlier, which is this model pipeline DB here. We're going to be collecting like data at all steps of the pipeline. So not only the actual training and what type of EC2 instance is being used and what are your hyperparameters. So think of hyperparameters as extending now into different systems level type things, right? So beyond these frameworks themselves, beyond what the algorithms give you, there are more knobs that you have control over that you can then, once all this data is collected, so here, one hyperparameter would be learning rate, and there would be a call to the pipeline DB. This isn't set up yet, but this would get it in. So it would be pipeline DB, let's see, tag, and it would be learning rate. Actually, it would be add learning rate and 0.025. And so all of this stuff, then you can mine all of this later and make recommendations. So as your enterprise is building more and more models, you could actually use all of the data that's been collected from all the models that have been trained and deployed up till now. And you can, so this is on the training side. So training side hyperparameters. You would also say pipeline DB add, and it would be like EC2 instance type, and it would be, what type is this? This is the G34X large, pipeline DB available memory, and it would be, I think this one is 122 GB, pipeline DB add utilized memory. And this is things that we're going to automatically pick up for you. So let's say it only used 20 GB. Pipeline DB add would be GPU utilization, peak GPU util. That would be 25%, something like that, right? So that's on the training side. But now keep in mind that there's optimization phase. So this is training phase, hyperparameters, training hyperparameters, optimization, hyperparameters. And this would be something like add strip unused nodes. And let's say we got rid of 35 nodes, pipeline DB add, what other optimizations? We'd say weight quantization, and it would be 25%, something like that, like 25% reduction in weight size or something, right? This is going to be something that you can plot, so probably just say 25%, something like that. And then at the inference, and for the next call, like next month, we'll actually have real live examples of this. And we've been collecting this data up till now on the community edition. We just haven't exposed it as this central pipeline DB. So inference hyperparameters, this is going to be request Actually, let's be even more broad and say runtime type is TensorFlow serving GPU. So that's actually just the physical runtime type, because we could actually have the same exact model that was trained, but we could have multiples of these. So this could be, TensorFlow serving CPU, TensorFlow serving, so we already have GPU. This could be TensorRT GPU, which is custom runtime by the NVIDIA folks that we are partnering, and I'll be demoing next week at GTC. I believe my talk is on Thursday. There's also plain old TensorFlow, Python. So this is actually what probably 90%, 95% people are deploying right now. They're spinning up a Flask app, which, by the way, I actually just registered noflaskapp.com. So if you guys want to go there, it'll actually just take you to pipeline. But yeah, so no Flask app. That's how strongly I feel like against Flask apps for model serving. I went and registered that domain. So Python. So this is actually using Python itself and completely avoiding all these optimized runtimes. These are C-based runtimes that can read your exported model out of here. And yeah, so you would, if you just had Python, and yeah, obviously that's most likely going to be Python TPU. You would then have, so we would already know the model type. This would be like, this would be TensorFlow, could be Caffe, could be R, could be Scikit, could be Chainer, MXNet. Yeah, we support all these. And then the other one, so specific to each runtime type, we would have, if it's TensorFlow serving, for example, we could have request batch size, and this is something we have control over. So we can actually say TensorFlow serving, queue up 50 milliseconds. So this is size in so milliseconds, 50 milliseconds. Every, let's say every 10 milliseconds, batch up everything that you can, and do that. You could also do, so the request window, milliseconds, request batch window. That's what I'm trying to say. Request batch size, this would be every 1,000 requests. Consider that a batch and pass it into your TensorFlow serving process. So that's really powerful. So keep in mind that most data scientists end like literally here, where most data scientists end their hyperparameter tuning. And it's because they don't physically have a way to even tune these other things or to try out other things. So yeah, so picture the ability to actually try out different profiles of EC2 instances. And the other thing here that's actually worth calling out would be like GPU type, which would be K80, could be P100, V100, could be the graph core ASIC, ASIC V1, could be TPU, right? So really this would be accelerator type. And it would be GPU underscore K80, something like that, okay? GPU V100, or if you want to say NVIDIA V100, GPU, something like that, okay? So, and so this would be Google TPU, NVIDIA, GPU V100, graph core, ASIC V1, some other companies, Cerebras, that's here in, those graph core folks I believe are in London, Cerebras, they have some code for it, but it's essentially an ASIC V1, something like that. So we can mine this data and figure out the best hyperparameters at all three phases: training, optimization, and the inference. And we tie all this together back inside of this PipelineDB, and we can start to make recommendations. Okay, so I think that's it. It's about an hour, a little bit less. I posted a bunch of links here. Any questions, please post them now. I'm going to be tearing down these instances here in a sec. So if you want to keep them alive, ask me a question and I'll keep them alive until we're done. Biggest difference between community and paid. Yeah, so paid, you pull it, you actually pull it into your own VPC, like you would install into your Amazon account. And community is wide open. So the biggest difference is like privacy, right? Biggest diff is community is open to the world. Paid is inside your enterprise, inside your company. So it's one of those things where we don't, and also we've the model, the PipelineDB is essentially collecting data in community, and that's for us to build up a large data set. And yeah, even if you submit like 25 different versions of Hello World, you know, something doing a simpler, right, like Hello World and like machine learning would be like MNIST or even linear regression, and you provide us with like a bunch of different hyperparameters, we can learn from that. So even the simplest models, but to actually mine that data specific to your enterprise, that has to be done with the paid. So yeah, and what's the other big thing? We're also some of the optimizations, some of the hardware specific optimizations are part of the paid. So we'll do some simple optimizations that are more general, but anything that's really geared towards your infrastructure, right? Like we see a lot of older GPUs that are being used, and you know these folks can do a bit of bursting into the cloud, but it starts to make, if they're like mixing and matching cloud GPUs, which are K80 and above, with their current GPUs, you know, they're a bit more high touch essentially, like versus community, which is pretty wide open. So don't put anything sensitive out there, just get kind of a feel for how the product should work. Yeah, good question. Yeah, so we do have a standalone edition that will be our first release, and that's going to be a single node that installs into your own VPC. And then that's priced differently than like the enterprise edition, which then we can join and tear up and like auto scale up and down, right, like multiple nodes. So it's, you know, from right, like our experience, really having worked at like Databricks and like NVIDIA and places like this, yes, obviously one node itself is super easy. And when you start getting into the distributed, like larger workloads, right, then right, there's just tons more like coordination that has to happen. There's a lot more on the tooling side that like we have to like provide. In terms of pricing, right now the thinking is more on the like runtime. So all of the tools that we're building are right, like ways to get you to use our runtime in production. And once you use the like pipeline runtime, you're actually gaining, you know, all of the logging and the metrics and all of the data collection. Oh, so that was one thing I actually didn't emphasize over here. So while there's the request batch size, you know, these are hyperparameters, but we're also logging. So there's training hyperparameters, and then there's training, I guess you'd call them like results, right? And this would be PipelineDB add accuracy. So this would be like training accuracy, you know, all the things that we're used to from scikits. And this would be 95% PipelineDB add training, or sorry, validation accuracy. And so, right, like we have ways to actually do this automatically so that we don't have to have you guys typing this every time. So we can inspect the actual pipeline itself, the scikit pipeline, the TensorFlow pipeline. And so there's that. Oh, so yeah, actually this would be, you know, we would say weight quantization true, and then we would say weight quantization results, and it would be, you know, 50% reduction, something like that. Quantization reduction, 50% less. So something like that. And this would be more on the optimization results. And then, of course, there's inference results. And so imagine having access to all this data, right? You're going to need Spark. You're going to need, you know, like TensorFlow to get access to these things. And you can, what our value add is that we're actually building the models for you, where, and they're packaged up in the actual product. So there's going to be, you know, sort of pre-canned like recommendations that will say, hey, it like looks like for this particular classifier that we've seen you guys deploy a few times, we're seeing strong signal in the let's see, right, like EC2 instance, for example. You've tried it on the G3, you've tried it on the P2, the P3. One other optimization here would be, so there's going to be accelerator type. There's also going to be the precision. So the weight precision. And that's going to be 16-bit or 32-bit, something like that. Precision bits. Okay. And let's see. And so you can train, this would be, for example, training precision bits. And then there's going to be an optimization part of this where it's going to be, so yeah, it's like essentially like related to the quantization, but you could say, wait, yeah, so actually let's just do that one, bits. And we'll say this is 8 bits. Okay. And what you would do is you would essentially not do this on a separate run, and you would get really different validation accuracy, different weight, like reduction type metrics here. And then all of this, of course, feeds into the inference. And so this is an area that we want to keep an eye on. And we'll say 99 percentile latency. And this is going to come in at, so latency milliseconds. And this would be 0.05. Or yeah, let's just keep it easy and say 5 milliseconds. And we'll say there's this other metric that we expose that people seem to really enjoy, which is, it's actually, I always like to group these. 99 PCT, latency, MS, 99%, something like that. We can see cost per prediction. And obviously this in combination with the EC2 instance type, this is pretty powerful, right? So this is where we're, and so let's say it's 0.000001. And this is a metric that we're already capturing, and we've shown it a bunch of times. I can show it again here, go back here. We actually highlighted here even, cost per prediction, see the dollar sign. So if we're doing this, predict, we're seeing right here it's 0.06. And yeah, obviously this starts to smooth out after a while, but this is kind of the real time, the last 60 seconds. You can certainly, as the model is running longer and longer, we can collect more data and see how it changed over time and that kind of stuff. But let's just say cost per prediction, dollar, something here, yeah, like US USD. Okay, so now what we're doing is we're deploying models. We're then using AI on top of AI to optimize our full complete pipeline. And this is the first time that you will see anybody doing this, by the way. This is complete, really end-to-end, not just model hyperparameters, but also system like hyperparameters, and not just at training, but also this new step that we're creating, which is optimization step, and then now the inference hyperparameters as well as inference results. AUC and F1 score, absolutely. Yep. Yeah, I mean, these for sure. So even on the inference side, so after a while, I get this, yes, I get this question quite a bit actually. So after a while, so let's say you are tracking, ad clicks, that kind of thing, and you have a 24-hour window. So the 24-hour AUC, now this is on the inference side, right? And, so let's say that's 0.7, right? So something like that. And yeah, so this would be 24-hour. We would then, have like maybe 48 hours, something like along those lines. And like this is a bit more complex. These typically use some other tool to aggregate this data and calculate it, something like Spark, things like that. So this would be, down to 0.3. Okay, yeah, thanks, Stephen. So you explained how different companies using paid version in production. Yeah, I don't want to make this a marketing thing. This is more just to update you guys on what we're doing. So for any questions on the product side, ping us. You can ping me, Chris at Pipeline, or contact at Pipeline. There's about 5 to 10 different ways to contact us. So we're also on Slack. Join slack.pipeline.ai. Hop on there. You can message us directly. We've got people all over the globe now answering questions and helping out. Let's see, some of the hardware stuff. Yeah, that's my own comments. Different companies. Yeah, but like high level for how people use this in production is, right, they're installing it inside. So basically it would be community, but running inside of their infrastructure and tied into what we've been spending quite a bit of time in a high touch manner on some of these larger customers is tying in obviously with their HDFS or with their specific object store. We're seeing a lot more real world hybrid cloud. We all kind of laugh about hybrid cloud, like it's fun in concept, but like no one's really doing it. And I'm here to say that that's actually not true. There are more people doing it. We actually we form partnerships with folks like Anaconda. And so any company that is typically focused on training or like ETL, so something like Databricks that doesn't have a very strong AI, like ML story, they have Spark ML, but there's no way to actually serve those models. That's where like we come in. So we have like REST APIs, you can get the models into the mesh. Into your own private mesh, right? So we're not in the business of a managed service running your models. We don't want your models. We have plenty of our own. And so this puts like your people that are responsible to actually maintain and keep these servers alive. We do have the economy of scale that's working in our favor, which is a lot of these folks on our front page here they've essentially found a lot of the high scale bugs, things that we don't necessarily notice in our own testing. And so we get a lot of feedback from these people, and they're helping us make the actual runtime just like rock solid. To kind of peek under the hood a little bit, we are using some of the Netflix open source and some of the really hardened. It's mainly because a couple of us come from there, and also because we trust, that type of model and that specific code. Yeah, and they're collecting data in a very similar way with the pipeline DB, and we don't spend we don't do any consulting or anything like that. We do like a 2 or 3 day jump start. Sometimes even longer for some of the larger customers that have these like hybrid cloud environments and these complex. But we do tap into your Jenkins, we tap into your logging system. So we have Datadog connectors, we have CloudWatch connectors. Like again, we're not collecting your data. This is all stays within your like cloud accounts or on-prem. Kind of scale. You see, yeah. So question about scale. Essentially, you know, these model servers are stateless, right? They're serving up predictions from the actual runtime, and so these things are horizontally scalable. So, you know, at like Netflix, for example, we would have 5,000 to 8,000 like model servers running. And so keep in mind that, you know, that's very different than having 100 training servers running, right? With these kind of bursty workloads. These are 24-hour workloads that are taking traffic and they're being auto-scaled. So in terms of the actual pipeline runtime part of it, you know, which is packaging up your model, if you follow Quick Start, you'll see it, and getting it out there and then participating in your logging. And, you know, your ops guys have full access to our model server logs. And our model server metrics, and you know we use all like the industry standards like Prometheus, and but we can tie into all of your monitors. So there's no there's some strong opinions in the pipeline stuff, but these are very common opinions. These are very well respected opinions, and like we're not here to rock the boat on that stuff. It's just not worth it. So we'll tie into your security. We're working on some like LDAP integration right now as well too. I thought I would never say those 4 letters again, but it starts to get really pretty necessary in this enterprise world. So in terms of the data collection, so keep in mind that this kind of data collection going into the pipeline database is not that high volume, right? This is on the training side, for example, this is every training run. So in terms of scale, right, like we're using, right, like Cassandra beneath the covers, and right, like we don't expose all this stuff to customers necessarily, not unless they actually want to like crack open the hood, but we can, right, like take in a whole ton of data if you are training, you know, thousands of models concurrently. We really don't see that, right? See maybe a couple hundred concurrents, but typically it's not that high volume. On the inference side, this is where we actually are starting to collect. So these are hyperparameters. So these are defined once when you package up your model and have it participate in the like pipeline runtime. And then on the inference side, we actually are collecting these metrics by like every 5 minutes, something like that. So it's not super high volume. It would be the volume of like a typical heartbeat, right, from the model server. That's and then these kind of things, these sort of custom things like 24-hour AUC, right? In order to create a metric like this or track a metric like this, this is very specific to your domain, right? So this is essentially creating labels on data, right? These are things like AUC and like the F1 score. These are for labeled data. And when data is coming in, that's new and unseen, you don't have a label, not for 24 hours or 48 hours when you can go run a Spark job and see of all of the impressions that were shown, right, like how many were actually clicked on. So this isn't that like high volume either, but we're certainly set up for it, right? Like our background is all scale, like we don't even really know how to do things, like not at scale. So yeah, this stuff's all been architected with that in mind. Yeah, like good question about the scale. On the runtime, it's essentially like infinite, as many. We do use Kubernetes beneath the covers. However, we've seen a couple people implement pipeline with Docker Swarm and had super good results. It's not something that we support first class, but for people that know Docker Swarm, it's essentially a collection of Docker images, or right, a single Docker image, for example, the model server itself, right, that is built with your model. And with Swarm, you can just infinitely scale it out. Something I didn't really talk about too much on the development or on the sort of workflow pipeline side is getting new versions of these models out. I've talked about it before, and we certainly do it in the workshop before workshop, but this is the ability to deploy multiple models flip the traffic or shadow, right? Like initially we would want to shadow and see how it's doing. And we're tightening up we just upgraded to the latest Prometheus and to the latest Grafana. They're on like pretty much the next whole major version. So there were some changes, and so some of those dashboards aren't very clean right now. But you would essentially be able to monitor not just system metrics of these models, but there's a view that we have of the actual predictive like metrics. So like the ability to on a two-dimensional plot in real time show how multiple models are predicting, right, like relative to each other. And yeah, obviously, if you want to extend that out into 24-hour AUC, then you could start to compare. But from a real-time standpoint, the use case we were trying to solve is pushing out a model and being confident that, so push the model out in shadow mode and be confident that this model is not just fraud, right? And the other model is, you know, success most of the time, and you know, fraud 10%, right? Like something like normal like that. So. Yeah, and then I think the other big piece, and I know I'm running out of time here, but would be, let's see, do I have an example here? So we're actually we're trying to finalize the final tooling if it's going to be something like right-clicking on a model and saying, so if we crack this open, we see this is an example like model directory. You would right click and say deploy, right? So that is not there just yet, but we would deploy it, and you would by default deploy it into shadow mode, and it ends up in the mesh, and it's got all the like load balancer is, you know, sending traffic to it in the best effort mode, but not it's just dev nulling the result, or that result is showing up in the dashboard. So we're just like hours away from like getting that working. We have all the REST API endpoints and all the CLI endpoints working. It's just more figuring out the best way to do it if we're going to build into JupyterLab or not. The last thing is, I kind of mentioned it here, when you fix the prediction that goes into the retraining. Let me show, let me see if I have a screenshot. I think I do in my PowerPoint here. Oh, and I mentioned Kafka, like integrating that with TensorFlow. That's actually brand new for 1.7. And I'm hopefully going to have that guy come speak. He's here in San Francisco. The guy that built that integration is he's a big like TensorFlow contributor and super cool guy. So I think he's going to come speak, and we'll record that and post it. So this is what I'm talking about here. The ability. So this is the sort of human in the loop. It's also a path to crowdsourcing. And so let's say human in the loop. What we're doing is, yes, like I mentioned, if there is a particular number that the classifier is confused, we'll see the confidence 0.1, 0.1, 0.1. You know, this is obviously fabricated, but this is something similar to like how this works, which is we'll actually detect during the request response that this is an unconfident prediction. We'll still return a value. We actually go back and forth on whether or not we should show what was predicted here, because we don't want to skew what the human is going to predict. So here it's just kind of generic, right? And you want the human. Now this doesn't scale that well. It's kind of per human, but this is why, you know, it's a pathway to crowdsourcing. And what's cool is that this is data right along those class boundaries, right? So this is the data that you do want to focus on and do want to like make sure it gets labeled and gets added back to the training process. Yeah, and this kind of opens up like a gamification to kind of make this fun. There's the short-term gamification. There's the obvious one, the number of like images that you relabel or that you like label, or the predictions that you correct. You know, get some points towards like vacation day, something like that. So this typically starts with just the data science team itself. They have their own private Slack channel, and they are starting to relabel, and then this gets kind of old after a few days, but then like there's nothing saying that you can't extend this and like open it up to Mechanical Turk or to Crowdflower, right? Like people that are familiar with this type of process, and so this is where you can just throw bodies at this kind of thing, right? And then the other thing too is that you would actually show this exact same image to multiple people and get a majority. So that way you kind of weed out, poor labelers, and they'll sort of naturally go away, or like we would have another like dashboard showing which people are not doing a good job, and then reassign them to like some other labeling that maybe they're better at. So, okay. Services, yeah, we're not in services, unfortunately, Stephen, but yeah, I know what you're saying. How lightweight is Pipeline to be run on a local machine? Yeah, so if you do the quick start, that's a good question about quick, that's a good segue to the quick start stuff. So this is how a lot of people start out with us. They find the quick start, and you can run it locally on so just as long as you have Docker. So it's saying click here to install Pipeline CLI. So it actually goes back to this screen. Follow these, make sure that you have Docker. We prefer Conda, but it'll work without Conda because it's just a regular pip install. And you can follow this. This explains all the different features. Now, keep in mind that there's a lot of things in this CLI, and this is the same as our REST like API as well too. But what you want to do is, so once you get that installed, you go back here and pull down these sample models, and you follow these instructions. So we have TensorFlow, we have Scikit, we even have a PyTorch, and this is actually training and deploying. So like when I say deploy, I mean more packaging, and then like as a Docker image with its runtime, and then the ability to start up that model server on your local machine. And as a bonus, if you're running the latest Docker with Kubernetes, you could actually follow the Kubernetes instructions. So you do the same thing, make sure you have CLI installed. And I believe the beginning of this was 1802, I think, maybe even earlier, because I seem to remember Kubernetes 1.8 being the like the original, and they just bumped up to 1.9, which is good because there's a lot of RBAC and security patches within 1.9. And you would follow these instructions, and you could literally run for like multiple model servers here. In fact, I think I even take you through, so you have to register. You could even register with your own private Docker repo. Some people have asked questions about that. I've tried to put in enough notes here where you can get by. And then you could use Istio here for some of the routing. So you can get very far with the open source to the pain of like my business guys and the investors and things like that, my sales folks. You can actually do quite a bit with the open source, right? But again, if you want some of the optimization, like value adds and the pipeline DB and that kind of stuff, that's where you'll want to like contact us. So yeah, and you can actually hit it with. So this is actually doing the routing. Second, so this is model variant A, model variant B. You could scale up model variant B. You can test either through Kube, or you can actually hit the REST endpoint. I think there was HTTP test up here, if I'm not mistaken. Yeah, and this looks deceiving. Oh, because the actual payload is in this test request JSON. So yeah, we have a lot of people that go through this. If you get stuck at any point, just ping us on the Slack and we'll get back to you right away. We have people 24/7 that are finding bugs, and we're fixing them as fast as they're like coming in. So I get a link to record. Yeah. So all recordings are posted to youtube.pipeline.ai. Yep. And we actually started a bit late, like at 9:15 or so. So really, we've only been going for about an hour. Okay. So yeah, see how far you can get with the quick start. There's a lot of stuff here, and which we know this is probably the longest quick start you'll ever see, but I always opt on the more info than less info. Okay, guys, thanks a lot. Thanks for sticking around. We actually have a lot of people that stuck around, so I appreciate it. Talk soon.